All right, welcome everybody. Everybody's doing good this morning. It is so nice to see sun. I teach really two night classes, and what's so nice now is they're kind of night 5 to 7. So nice now to leave and it's still light outside. What a difference that makes. Feel like I have part of my day left.
A couple weeks ago, when weather was no bad, I went up to, I went out of town to get away from bad weather.
Yeah.
Went up to Seattle. Weather was better.
You went to Seattle. It was better up there. That shows you what's happened. When people actually go to, my mom used to live up there for a little while. Yeah, that's funny. Yeah, my brother lives up in Oregon, who's actually coming down to visit me today. But that's strange when you start going up to that area because the weather's better. I don't know, maybe the world's turned upside down or something. All right, let's get started. So today we're going to start the discussion on subnetting. So let me explain a little bit what subnetting is here. So we're going to take this relatively slow, as you can see here, and I'm actually going to have to bring up my ink to go, I think. Hopefully it plays nice here. So yeah, let's get started here. IPv4 subnetting. So like I said, we're going to take this slow. It's not that it's difficult. I'll explain the challenging part of all this is that we have IP addresses are binary bits. And the way we represent these addresses are in 4 8-bit octets. We convert every 8 bits to a decimal number, which is fine. But when you want to start doing things within those 8 bits, you've got to then think binary. So let me explain a little bit about what subnetting is. And I'm going to actually, let me do this here. This was my, we'll see how this works here. This was my idea before we, as I was walking from my office to the classroom here, I had this idea to do something here. So let's say we have this network here, 10, 0, 0, 0. Okay, I'm going to make this what we call a /8. So that means this is the network part. And these are the hosts. So what does that mean as far as my host devices? Let me bring up my little PowerPoints here so I can grab some icons that I was using. Let's see here. Okay, what that means is our devices here, all these devices here, will have an IP address starting with 10 and then anything here. Again, this is the host portion here. Okay, so this could be 10.1.0.100/8. And again, this is the network portion. And then this 1.0.100 is the host portion. We could have another host here that has the address 10.2.0. I don't know, could make it 100. It's still different, right? 100. Okay, /8. Because this is the network portion and this is the host portion. This host portion here is what needs to be unique. Okay. So on a network like this, we have 24 bits here for the host. Okay, that gives us over 16 million devices we can have in this single network. And this is how other networks would see us, is just as the 10.0.0.0 4/8 network, and everything that belongs to that is inside here. What we're going to be doing today is taking this network and we are going to divide it up. Okay. We are going to divide it up into 4 different networks. So we're going to take this 10,000 that the rest of the world sees us as, and we're going to divide it into, we could divide it into what we call /16s networks. We could make this network address here 10,100 would be the network address. Now this, we could see that the mask will change. We'll talk about this more in a moment, but this becomes the network now. And everything inside this network must begin with 10.1. And in this subnetwork, we call it a subnetwork because it's a smaller subdivision of this larger /8 network we just saw previously. So the number of hosts you can see is less. We have only 16 bits for the host, or 65,000 plus hosts. But everything in this part of our network must begin with 10.1. Okay, so yes, we'd have to change this address or this mask here to be a /16. Maybe this subnetwork here is our 10.200/16. That's a slash. So this 10.2 is the network portion. And then these last 16 bits is the host portion. Again, everything in this network must begin with 10.2. Okay, so we'd have to change this mask to /16. And really our host now starts here. Right here. The first 2 decimal numbers belongs to the network. Okay, and we could do the same thing here, by the way, 10.3.0.0/16 and 10.4.0.0/16. This means everything in this part of our network has to begin with 10.3, everything here with 10.4, and everything will have a mask of a /16. So this is the network portions, and this would be the host portions. Now, as far as the router goes, we now would have to have a different router interface for each one of these networks. So the router would have an IP address that belongs to each one of these 4 subnetworks. And that's where we're headed. So we are actually subdividing our network. And there's some reasons why we want to do this. We'll talk more about that on Monday. But the main reason is we want to create smaller, more manageable networks. Okay, that includes, things for like broadcasts, ARP requests. We want to limit the number of broadcast ARP requests. We want to limit parts of our network, restrict those users to certain services in our network. We might have different subnets for different functions. For example, our engineering department, sales department, human resources, our guest network. Okay, they all might have different access to different types of services in our network. It also limits, if there's a problem in our network, it typically will limit it to that part of our network. All right, so let's get started. Hopefully that helps a little bit. But if not, don't worry, we will get there right now. Exit out of my ink to go so it doesn't cause me problems. So what is subnetting? Subnetting is nothing than dividing a big barrel of apples here. You have a barrel of 100 apples and dividing it into smaller baskets. In this case, we have 10 baskets of 10 apples each. Okay, still have 100 apples. Subnetting does not give you any more addresses. What it does is it helps you manage what you have until you put them into smaller networks. Talk more about this. And really every network, as far as a public IP address, we'll talk about private and public more on Monday. But when, especially public addresses, every public address is really a subnetwork of some other larger network. For example, we saw this on Monday but the regional internet registries like Aaron, they get just one. Well, let me put this up here. They get just one of the subnetworks. Remember that Aaron got a subnetwork 207.0.0.0/8. Okay, I mean, this was the network portion here. Aaron got all that. What Aaron did was they divided that up into giving, Scenic a slice of this. They gave Verizon a slice, and all kinds of other ISPs, content providers, mobile providers, all get different slices of this one piece of the pie. Okay. So different ISPs will get a slice of this, and we saw that before with Verizon. We'll see more of this in a moment. Okay, so in an IPv4 address, what happens is this. You have a network address and you have a host portion. When you want to subnet it, so some provider, let's say, gives you, like here at Cabrillo, our ISP, Scenic, gave us a network address, which is this blue network portion. Internally, we create our own subnetworks. But what we have to do is we actually have to borrow bits from the host portion to create subnets. Similarly, they gave us a barrel of 100 apples. If we want to use it as one big barrel, we can do that. But if we want to subdivide it, it's up to us, and how we subdivide it is up to us. Okay. So subnets are created by extending the bits in the subnet mask. So for example, let's say our ISP gave us this. Now I'm showing you private addresses, okay? But let's just say we're using this private address, 10.0.0.0/8, 255.0.0.0. That means this is the network portion, this is the host portion. This is one network. We'll see this in a moment, of 24 million hosts. But if I want to, I can borrow bits. I can extend this mask. So notice I'm extending the mask from 255.0.0.0 from /8 to /16. Another 8 bits here, 255.255.0.0. Okay, this is what's going to create the individual subnets. Okay, here's a simple example. So Aaron, a regional internet registry. Now I'm using private IP addresses here. Okay, of course, these would not be private. Maybe I should redo this to show an actual IP address to 207 next time. Okay. But let's say Aaron gives ISP-A 10.0.0.0/8. Okay. And gives other ISPs maybe 11. So what's some other ones? ISP-B might get 11.0.0.0/8. Maybe ISP-V got 12.0.0.0/8. All right. Well, ISP-A, what do they do with that? They have this total, one big network of 16 million total addresses. Okay. This allows the ISP to then subnet this and give out different portions of this address. Now they can't touch this, but they can touch this here. Okay, they've been given a barrel of 100 apples or 16 million apples, they can subdivide it. Okay, again, they're going to borrow from the host to create those subnets. All right, so they cannot modify this, the 10. That came from Aaron. Okay, but what they can do is modify the host portion. So they can extend the mask 255, 255. So we went from 255,000 to 255, 255,000, from /8 to /16. So from 8 to 16. Now all of this represents the network. However, the first 8 bits, that 10, they can't change that. Okay, but they can manipulate this. Let's see how they do it. Okay, so now we're going to create smaller networks. And the way we identify that these or indicate these are individual networks is we've extended the mask /16. The world may still see us as this. They see our company as 10,000. Anything beginning with a 10, but internally, as an ISP, let's say, we're going to subdivide what was given to us into these subnets: 10,000, 10,100, 10,200, 10,300, 10,400, 10,500. I can keep on going until 10,254,000, 10,255,000. So what this has done is given me 256 subnets. So instead of having one network, of 16 million hosts, I now have 256 subnets. I have more networks, but they're smaller. I divided my barrel of apples into baskets of about 65,000 hosts per subnet. And if we want to look at that in binary, let's do that. So here's the 10,000. And all I'm doing here is I got to leave this 10 alone, the first 8 bits, because that was given to me. But I've borrowed these 8 bits, extended my subnet mask by 8 bits. So these are now subnets. And I'm just incrementing it by 1 until I get to from 8 0 bits to 8 1 bits. And there's all my subnets. Okay. How are we doing so far? Is this making sense? Okay. All right. So what we've done is ISP-A now has 10,000/8. They were given this. Okay. They had one network of 16 million hosts. Okay, -2. They couldn't allocate one for the network address and one for the broadcast. They couldn't allocate those 2 devices. But now they've created up to 256 subnets. Each subnet has 65,500. Oops, I got a typo there. 536. Right? Right, David? 536, right? Or any of you guys? I think that's right. Not 556. That just doesn't sound right. I've only been saying these terms for 30 years. Okay. What's 2 to the 16?
Would have 65,536.
That's what I thought. Okay. All right. Thank you. Okay, 65,536 hosts per subnet, but remember, each one of these subnets is going to lose 2 available hosts for host devices, or lose two IP addresses for host devices, because each one of these requires a network address and a broadcast address. Okay. Okay, I'll correct that. I can't. All right. So we have now ISPA can actually give a /16 out to all these different customers. So you can see that the internet is really just a subnet of subnets. It just keeps on getting divided. So we have customer A here, customer B. Yeah. So good question. The question is, this is one of the reasons why IPv4 survived. This is one of the things that they had to do to allow better, more efficient use of IPv4 address space. But apart from that, probably the biggest thing that probably got you through the 1990s, but NAT and private IPv4 addresses, that's what did it. Yeah, this subnetting was one of the things that was not, so that's a great question. Subnetting was not one of the things that was initially part of IPv4 addressing. Matter of fact, when you got an IP address, you got a /8/16/24. And even internally, there wasn't a way for you to subnet. So let's say you got a /8 network, 16 million hosts for Cabrillo campus. We didn't, but 16 million hosts. Then you decided, I want to open up a Watsonville campus. At that time, prior to the mid-1990s, there wasn't a way that said, well, you've already got 16 million hosts, divide up your network and give Watsonville part of that. No, what you had to get was another, maybe a /8 or /16 or something network. So this actually helped internally, where you didn't have to go keep on requesting addresses. You could more efficiently, effectively use what you had. Does that make sense? Yeah, good question. Okay, so let's look at customer E here. 10400/16. That's what they got. 255.255.00/16 mask. Now, each one of these customers, by the way, like customer E here, they get 10.400. They can't touch the 10.4. That came from their ISP. Can't touch that. They can touch the host portion. So let's take a look at what they can do. So here's our 10.400 network. Okay. So here's our 10.400 network. Notice the hosts in these networks are all going to have an IP address that begins with 10.4, 10.4, 10.4, 10.4. I sound like a trucker. Remember those days? See, I don't. Sorry to point out that. All right. 10.4. Wasn't that a trucker thing or a yeah, 10.4.
My first company.
Yeah.
Was installing CB radios for people in the 70s.
CB radios, that's what it's trying to.
My upload. CB radios in cars and houses.
Yeah.
We made a bunch of them. Because back then it was super popular.
Yeah.
Like 70s.
See, people don't even know what CB radios are anymore, but they were a way that, well, especially truckers, but my friends had a business in San Jose, did the same thing.
We just go around every weekend. We go around and install radios to people's cars.
Yeah.
And we made a pile of money.
It's how truckers would talk to each other, is how all that came from, right? Yeah. What's that?
People still do the same business. Basically, this is the CarPlay.
Oh, CarPlay.
Yeah, but yeah.
Oh, yeah. Okay. Interesting. Yeah. Anyway. Okay. Oh, cool. Well, even the router here, by the way, has an address 10.4. and the host portion. Now notice the router's IP address here, by the way. Okay. Notice this router's IP address. That's the default gateway for all these devices. And you'll notice that all these devices have an address that begins with 10.4. They all have a subnet mask 255.255.00/16. Okay. All right. Question? Yeah. Subnet mask what? You have to, so when you subnet, you have to change the mask.
Oh.
Yeah. So that's what subnetting really is modifying the mask to show that now, when you modify the mask, you're now indicating that this is the network portion. So when we extended this mask to include this second 255, it's now saying that this is first 16 bits, 2 decimal digits, is the network portion of our address. 10.4? Okay. All right, so this is what's actually happening on one of our hosts. We have that host 10.4.16.66. Here's its mask. Okay. When it does the bitwise AND operation, it copies the first 16 bits where the ones end and the zeros begin, and there's our 10.4. Then it puts all zeros in the host portion. That's how it knows what network it belongs to. Here's the first host in that network, all zeros and a 1. The last host, all 1s and a 0. The broadcast, all 1s. We look at the addresses. This is how, when this host has this IPv4 address and this subnet mask, this is how it knows I belong to this network. It's by doing that bitwise AND operation. Oh, can I spell AND correctly? That bitwise AND operation that gives us this here, gives us the network address. Okay, and again, the first host, first host will be all zeros and a 1. The last host, all 1s and a 0. And the broadcast, all 1s. Now notice these 16 bits, as indicated by our mask, all 1 bits here, they don't change. They're all the same. Can't change that. But we can manipulate these host bits. Okay. Any questions on that? Is this making sense? Okay. And by the way, I do have all this in your little handout here. So actually, that's that one there. I think it looks like it's on page 3. All right. Okay, so what this gives us is this: 16 host bits. What does that mean? Well, the number of hosts we can have on our network with 16 host bits, that's these bits here, whoops, that's these bits here. The number of hosts we can have is 2 to the 16th number of host bits minus 2. Okay, minus 2 because we can't include the network and we can't include the broadcast as far as assigning those to devices. But everything in between from 0.1 to 255, 254, we can assign to hosts. And I did my math correctly there. 65,534. Okay. Okay. So looking at the bits of subnetting actually makes this easy, believe it or not. Okay. Again, the issue is we actually, here's our subnetting. We have to borrow bits from the host portion to create the subnets. Okay, so when we do this on what's called a natural octet boundary, it makes life easy. But subnetting within one of those 8-bit octets, well, sometimes we have to go convert everything to binary. I'll show you that in a moment. Okay. So, can we, if I have 10.4.0.0 network, okay, instead of, let me back up here. Let me show it this way. Add this right here. Okay, see, okay, that's what I want to get to. All right. So notice, so we had created these 256/16 networks, right? And each one, we just showed where this customer here, hey, we can create, what we have a network here of 65,536 hosts. But could we take this one here, maybe leave these alone, or maybe they go to other customers? Could I subdivide this network? Could I subnet this? Yes, certainly. Can I have a barrel of apples divided into 10 baskets and then take one of those baskets and subdivide it into smaller baskets? Certainly. So with this customer here may say, you know what? I'm going to subdivide all of this into smaller subnets. Let's see what we can do with that. So instead of having one network with 65,536 hosts in it, we can instead create smaller networks. Let's do that. Okay. So what I'm going to do is I'm going to, instead of using this network 10.4.0.0/16 as one big network, I'm going to once again extend the mask by another 8 bits. Okay. And what I'm going to do is that's going to give me more networks. Let's take a look. Okay. So what I've decided to do, again, instead of taking this 10.4.0.0/16 network and using it as one big network, I'm going to break it up into smaller networks. Okay. I can't do both. I got to do one or the other. So what I'm going to do, and how am I going to break it up? Well, I'm going to make my life easy. This is what I've been doing so far. We've been subnetting on what's known as natural octet boundaries. What do we mean by that? What we mean is we went from a /8 to a /16. Okay, remember, this is where our dots are in our address. Now we're going to extend another 8 bits to a /24. When we do it on these natural octet boundaries, it's very easy, okay? Because all we have to do is count in decimal. Okay, but we'll see that we don't have to do it that way. We could do it anywhere in between, even right here. But then we got to do a little binary decimal stuff there. We'll look at that later, maybe today. All right, so what I'm going to do here is I'm going to use this third octet. Now, as before, I'm starting with 10.4, so I can't change that. But it's this third number here that I've modified. So this third octet right here that I've extended now to be part of our, this one here is now part of our network. Okay. So I can go 10.4.0, 10.4.1, 10.4.2, 10.4.3, keep on going all the way to 10.4.255. So what I've done is I've taken a network that had 65,000 hosts, one single network, and I divided it into 256 networks of, well, let's see, 254 usable host each. Let's take a look. Okay, so here was my original network, 10.4, not, the 10.4.0.0/16. Okay, that was my first host, last host broadcast. But I decided, no, I'm not going to use it as one network of 65,000 hosts. Instead, I'm going to take 10.4.0.0 and I'm going to extend the mask by 8 bits. And this, I'm going to make this part of the network portion of the address. Whoops. Okay, so that's where I get, by extending it by 8 bits, I now, this third number here is now part of the network portion. But I can manipulate that. Okay. So maybe I'm a company that got this address, 10.4.0.0, from my ISP. And internally, I want to subnet. Now, by the way, if you internally decide to subnet, your internet service provider could care less what you do, okay? They still look at you. Let me explain that a little bit. Doesn't affect them. So here's an ISP, okay? And let's say, since we've been using the 10 network or everything, let's say this ISP got everything 10.0.0.0/8. Okay. That means they could hand out to, let's say, Gavilan College. And I'm using private addresses instead of public addresses here, but that's okay. Maybe they got 10.1.0.0/16. Okay. And maybe to Cabrillo College, we got 10.4.0.0/16. Okay. Now, what does that mean? We have our network here. We have a router. We're talking more about routing coming up. Okay. We connect to our ISP, this ISP here. They say any packets with a destination IP address, any package with a destination IP address that equals 10.4.anything.anything. But the destination IP address begins with 10.4, they're going to send it to us because that's who has this network. Everybody okay with that? Okay. So let's say we don't subnet. Okay. So all of our devices are 10.4.0.0 or 10.4 something something. But let's say we do subnet. We decide internally to subnet as 10.4, and then this will be the subnet ID, and then the host. So we're going to do /24. So internally, maybe we have a 10.1.0.0. Whoops. I'm going to start with 10.4 there. 10.4, maybe 1.0/24 network. We have a 10.4.2/.0/ make the slashes better, 24. We have all these subnets. We took our 65,000 barrel of apples and dividing it into smaller baskets of 254 each. So internally, we'll need to route. We'll learn about this later and more in other classes, but we'll have maybe, the router different interfaces to these three different networks. We do what we want. That does not affect the ISP. Does that make sense? The ISP says, I'm still sending everything 10-4 to you. What you do internally is up to you. I like this. Okay, so that's what we've done is internally we created these subnets. So now instead of having one network of 65,000 plus hosts, we can have 254 subnets or 256 subnets of 254 hosts each. Okay, so now what do we have for subnets? We have our host bits are 8 bits. That's 2 to the 8th minus 2, or 254 hosts per subnet. Now we're losing 2 hosts per subnet because every subnet, we can't assign the network address or the broadcast address to a device. How many subnets do we have? Count the number of bits you subnetted by. Our subnets from what we were given and what we borrowed from the host to create those subnets, what we extended our subnet mask by is 8 bits, 250. So now that's 2 to the 8th, which equals 256 subnets.
It also means you're losing 512 addresses.
You're losing 512 total addresses, 2 per subnet. Yeah. Now there was a time, you don't have to know this, but because I like to talk about old stuff. It was about 20, it wasn't until about, geez, when I say, oh, it was only 20 years ago. Yeah, it was only about maybe 15, 20 years ago that you couldn't use the first or last subnets. I won't go into the history of that, but anyway, now it doesn't matter. Okay, so before we were one big network, 65,534 hosts. Notice that this host had an address 10.4.16.100/16, and a mask of 255.255.0.0. So if we're one big subnet here, okay, everybody has a host IP address. In this case, the last 2 octets. Everybody has that mask, 255, can't change that. But what we did was now we changed it. Internally, we created all these subnets. Okay, so now here's that same host. But notice that third octet, 10.4.16, that 16 is not part of its host anymore. That means it's in the 10.4.16 subnet. Because the mask is 255.255.255.0. So if we saw an address like this now, 10.4.16.100 with this mask, that means the first 3 octets, 10.4.16, indicate what subnet it belongs to. Okay. So we went from PCA having the same IP address, but now, once we subnet it, it has different subnet masks, which means, oh, you're no longer on this one big network, you're now on this smaller network. It'll also have a different default gateway address. The default gateway address has to be on the same network. So notice our router here, the default gateway, has an IP address on the same subnet as the device, 10.4.16. We gave it the first address, .1. This network here had 665,534 possible devices. I got it right there. Here, though, it's just one device on a smaller network of 254 possible devices. So think of something like an ARP request, a broadcast. A broadcast in a network like this, all devices are going to see it. A broadcast in this network, like an ARP request, only those devices will see it. As far as configuring the router, so we can design this in various ways, but I'm just showing you here that the router is going to have an IP address on these different networks or subnetworks. Whoops, sorry. So this router here has an IP address. Well, let me see, what am I showing? 10.4.0.1, 1.1, 2.1. Oh, this other address. This address down here, that's its outside address here. But 3 addresses on different subnets. Okay, let's do this. Let's take a little break. Take an 8-minute break and we'll come back and talk a little bit more about this stuff. How are we doing at home? All right.
Rick,
Yeah.
We're gonna talk about how this is handled in a Wi-Fi context at some point. And
Uh,
I can see assigning this to interfaces on the router.
Let me-
Switch. How do you assign this to?
Okay, so we've seen what subnetting is. It's basically taking one big network and subdividing it into smaller networks. And you can subdivide and subdivide until you have no apples left to split. Okay, so we've seen that. 100 apples, 10 baskets of 10 apples each. Really, we only have 8 apples each because we lose 2 apples per basket. But we can also, as we'll see here in a moment, or see when we come back, we can take any one of these, one or more of these baskets, and subdivide it further as well. Keep on going until we have no apples left. Okay, you can't split an apple. You split an atom, but not an apple. So why do we subnet? Okay, so first of all, the terms subnet and network are interchangeable. That's really, every network is a subnet of some larger network. Okay, maybe not if you internally use a private address and never subnet it, but public addresses, yes. So one of the things is we talked about is it creates smaller broadcast domains. Okay, it's also going to limit the amount of traffic on those network segments, because not just broadcast, you have unknown unicast. When a switch doesn't know about the destination address, it floods it out all ports. It also provides some low level of security, kind of start to segment your network, depending, on sales, engineering, HR, guest networks. And then you can decide, which parts of your network have access to what other parts of your network, or what services. And once again, how your ISP sees you doesn't change, no matter if you subnet or not. So here we have a 10.50.0.0/16 network. If you subnet it, the ISP doesn't care. They're still sending you everything with 10.50.0.0. Okay, and how you subnet this is up to you. Okay, you get so many host IP addresses, and you can use it as one. You can use it as a single network if you want. But if you decide to subnet it, you can do it like 10 baskets of 10 apples each. But if you want more apples per basket, more host addresses per network, then you're going to have fewer subnets. Okay. And like I mentioned, you can take one of those one or more of those baskets, one or more of those subnets, and subnet it further if you want. Okay, so so when designing a network scheme, usually you go into an organization and they've already got it, okay? And you've got to work with what they have. Now, this is beginning to change with IPv6. IPv6 subnetting, I'm going to teach it to you in 5 minutes. I could do it in 2 minutes, actually. I could do everything that you really need to know about subnetting, for the most part, in about 10 minutes. All right. You usually do a network requirement study, decide how you want to divide up your network, how you want it to flow. You're going to be looking at things like performance, analyzing network traffic, security, how you segment your different IP addresses, develop some kind of assignment plan, addressing scheme. This is where you see things like the first address of every network is the default gateway. You don't allocate the first certain number of addresses using DHCP. You start at a later number so you can have static addresses. You assign your switches certain addresses. Okay, but we'll see that IPv4, one of the reasons we subnet as much as we do, and the reason why it becomes a little bit more painful is because of address conservation. A lot of what we have to do is, hey, I only have, I was going to talk about this next, so many public IPv4 addresses. How do I best divide that up? Now, you will have some private addresses, which is less of a concern. But in some major organizations, when you start talking about the ISP level or major companies like FedEx, Walmart, and those, Facebook, Google, the number of private addresses is not enough anymore. IPv6 address conservation is not an issue. It's much easier. It's all about making your life easier. Okay, so public and private addresses. So first of all, internally, you can use private addresses. So yes, you can use this 10.0.0.0/8, have over 16 million devices. You can subnet very easily on a natural octet boundary. For example, I could take this network here and I could subdivide it one of two ways. I could do a /16. Okay, that would give me 256 subnets at about 65,000 hosts per subnet. That's one option. Or I could take this same /8 and I could just say, I'm going to make it a /24. What does that mean? That means I'm going to use these two numbers, the second and third numbers, as part of the network. That gives me 65,000 subnets of 254 hosts per subnet. Now, what I might really want to do is use this one here. Let me get rid of this. I might say, you know what? I'm going to go with the /16. I'm going to go with 256 subnets of 65,000 hosts each. But I might take some of those /16 subnets and create /24 subnets. By the way, we'll talk about that on Monday. That's known as VLSM, variable length subnet masks. Nothing different than taking an existing subnet network and subnetting it further. Okay, but where IPv4 really becomes tricky with subnetting is right here, where our public IP address space. We only have so many public addresses. If we start subnetting here, we really have to think about how many public IPv4 addresses we have available. Okay. I think I just got done saying all that. Don't worry about Slack and stuff. A router is required. Okay, once you start taking your network and subnetting it, you're going to need to change the router or add routers to recognize those subnets. So as soon as you subnet this, you're going to have a router interface that belongs to this subnet and a router interface that belongs to this subnet. And of course, they'll belong to this network as well. All right, let's do this. When we come back on Monday, we're going to do an exercise together before we do. But we're going to look at what happens when you subnet within the octet. Okay. All right, let's do this. I just got a couple more things I want to wrap up here. Let's do this in-class assignment, and I also got a participation quiz for you. This is relatively painless. This is all about IP addressing, not subnetting. Okay. In a typical operational network. Yeah. So that means you want devices to be able to reach devices in its own network and other networks as well. All devices in the same IPv4 network will have the same, will they have the same network portion of their IPv4 address? Will it all be the same? Yes. Okay, that network portion, they're all going to share. Will the host portion be the same on all devices? No. Will the subnet mask be the same on all devices? Yes. Will they all have the same IPv4 address for their default gateway? Yes. Now, this doesn't have to be the case, but typically, will they have the same IPv4 address for their DNS server? I'm going to just say yes here, but it doesn't matter. But usually when a DHCP server gives out that information, it's giving it out per subnet. Will usually get, not always, but give out the same DNS server address of the DNS server.
If assigned by the
If assigned by the DHCP server. How do most client devices, your computer, get its IPv4 address, subnet mask, and all that stuff? Yeah, from a DHCP server. How do most routers, servers, printers get their IPv4 address? Another information, they get it statically. Yeah. My home network is 192.168.1.0/24. My network address and IPv4 addresses of all my devices will be the same as addresses on other networks all over the world. Is that possible? I guess is what I'm saying. Yeah. Because they use private RFC 1918 address space. The devices within your company's internal network all have an address that begins with 10. This is also private IPv4 address space and may be used by other networks all over the world. Is that true? Yeah. This is what's kept IPv4 alive since 1995. The address on my computer at home is 10.00.75. And the address of your computer at your house is 192.168.1.50. This means that your computer and my computer can communicate without the services of NAT. Can we communicate with each other just without any network address translation? No, That would be false. We need NAT and maybe some other things like port forwarding. NAT, network address translation, allows thousands of internal blank addresses, IPv4 addresses, to be translated to a single blank IPv4 address. Yeah, from private, thousands of private to a single public. Now, I need to just mention, NAT really doesn't care what is private and what is public. That's just up to you. You can translate, and it happens. ISPs do this, private to private, because you're running out of public IPv4 addresses. But what you translate, NAT really doesn't care. Usually the router that performs NAT is the router between your network, you at home or at work, and the network connecting to your Taco Bell. Yeah. Your ISP. I know where I got Taco Bell.
I knew, and then you went, and it was more predictable into but I decided to talk about.
Nothing. I gotta say, for me, Taco Bell is always kind of a good fast food call if I haven't been there in a while. But when I was younger, it's a problem when you go, much younger, go to the local Taco Bell and they know your order before you walk in. That's not good, by the way. Okay. Well, one last note, they have enchiritos. Remember those things? They look like, yeah. I went to El Palomar downtown Santa Cruz one day years ago, and I ordered an enchirito, and the waitress, she took offense. She goes, "That's Taco Bell. You mean enchilada?" I go, "Yes, sorry. Oh, sorry." I said, yes, enchilada. A small coffee, yeah. Or going into a small independent cafe and order a grande, a frappuccino or something. Yeah. All right. Number 9, when a packet leaves your computer going to Amazon or Zoom, before it reaches your router, the source IP address of that packet will be a what? Typically, private address. Yeah, it could. Yeah. And there are some networks like at UCSC, their wireless network, and I think their residential network uses public address space. Why? Because they had enough public addresses years ago. They don't need those public addresses right now. And why touch it? It works. So it's really strange to be on their network, on their Wi-Fi, and it's like, I got a public address. All right, last but not least, then I'll let you go. Oh, participation quiz, then I'll let you go. When Amazon and Zoom or any one of other servers accessible over my grammar, any of these public servers, Amazon, Zoom, whatever, receives an IPv4 address from your device, the source IPv4 address of that packet will be public. Yeah, they're not good. Yeah, private addresses are not routable over the internet. Okay, one last thing before you go, participation quiz. Let me give you the 3 questions and the 3 answers. I'll even just put them right up here so you can see them. Which Dr. Seuss character did Rick mention? Sam I Am. I don't know why. Which children's book did Rick mention? Pippi Longstocking. I don't know if these are still a thing. I think Curious George is. Homer Price is. I know nobody knows Homer Price anymore. Which candy bar did Rick mention? Milky Way. Okay, I'll let you go. So we'll talk about subnetting, finish that up on Monday. Have a good rest of your week. Cameron, have a good week.